All right, so we've been working on the unit circle, and the unit circle can feel really intimidating at first. There's a lot of information on it, but once you really break down what the unit circle is, you realize that it's the same information that's just sort of repeating over and over and over and over again. And so the unit circle just comes from this idea that it is useful to think about a circle where the radius is equal to 1. And that's what the word unit means here. That if you go from the middle of the circle to the edge of the circle, the distance that you travel is 1 unit. And so I can travel 1 unit to the right, I can travel 1 unit up, I can travel 1 unit to the left, I can travel 1 unit down. And those are going to be four of the many points that are on the unit circle. And we can even label those points 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Now, obviously, a circle doesn't really have a starting point or an ending point. So we just decided, mathematicians just decided, that we should start right here. This point right here is the start. Any point could technically be the start. So what we're doing is we're just making an agreement. We're going to start at positive 1 comma 0. It kind of makes sense as a starting point because it's the place that has an x value of 1. And that's as good of a starting point as any. From there, we travel counterclockwise. And that might be counterintuitive because, it might be nice if we traveled like a clock does. But we're traveling counterclockwise along the unit circle. And it's nice to do that actually because then your first chunk of numbers are all positive x and positive y. That's called your first quadrant. Then you keep going counterclockwise. And in your second quadrant, it's not true that they're both positive anymore. Now, because you're on the left side of the graph, you have a negative x value. Your y value is still positive because you're on the top half. Then you continue to travel down here to quadrant 3, finish up your journey in quadrant 4, and you can spin as many times around the unit circle as you want. Okay? So, what we're going to do is we're going to talk about two different ways of describing the angles. And I think that's one of the big challenges for students when they first see the unit circle is that there's these two different units of measurement. They're called radians and they're called degrees. And there's a way to convert between the two of them. It's similar to how we've got inches versus centimeters. There's often a situation where there's just different ways of measuring the same object, and sometimes it's annoying to deal with, but some people prefer to use one measurement, some people prefer to use another measurement. In some contexts, I will use degrees, in other contexts, I'll use radians. It just sort of depends on the situation. So you need to know how to do both. So degrees are the things that we're most familiar with. This would be 0 degrees because it's our start. This would be 90 degrees because it's a quarter of a turn. 180 degrees is a half turn. 270 degrees is 3/4 of a turn. And then 360 degrees is a full circle. So none of that, I hope, is too crazy. We're just talking about spinning around a full circle. Radians are another way of measuring the angle, and they're based on this idea that the circumference of a circle is 2 pi times its radius. And if we're talking about the unit circle, we know that our circumference is just 2 pi times a radius of 1. In other words, it takes 2 pi to go around the full circle. So what I'm going to do is write all my radians in terms of purple. 0 degrees is the same as 0 radians. And 360 degrees is the same as 2 pi radians. Because if I start here and travel one full lap around the circle, I've moved a distance of 2 pi. One full circumference is 2 pi radians. Half of a circle is going to be half of the circumference. So instead of 180 degrees, I could say that's the same as 1 pi radians because 1 is half of 2. So 1 pi is half of a circle. 90 degrees is half of 180 degrees. So I can say that 90 degrees is half of pi radians. 1/2 pi, you could do 0.5 pi or pi over 2. 270 degrees is maybe a little trickier for people, but think about what is halfway between 1 pi and 2 pi. You might say 1.5 pi, and that's totally correct. 1.5 pi is the same as 3 divided by 2 pi. So we'll usually say 3 pi over 2. One of the things that I want you to practice is just thinking about fractions and how fractions work. I like to think of it as 3 pi over 2 instead of as 1.5 pi, because then I can count up by pi over 2's. This is 0 pi over 2, 1 pi over 2, 2 pi over 2, which can reduce to 1, 3 pi over 2, and then 4 pi over 2, which reduces to 2 pi. You can keep counting up like that as many times as you want. Next up, we'll talk about moving halfway in between those values. So if I move 1 unit away from the origin, I'm going to be halfway between my two other measurements. So I'll have half of 90, and I'll have half of pi over 2. Well, what's half of a half? Half of a half is a fourth. And once I have that basic radian measure for the green angle, I can find the other 4 green angles that are at 45 degrees. And the way I can do that is by counting up by pi over 4's. So here's 1 pi over 4. 2 pi over 4 can be reduced. Here's 3 pi over 4. Here's 4 pi over 4, which reduces to pi. Here's the next one, 5 pi over 4. Down south is 6 pi over 4. 6 over 4 is the same as 3 over 2. And then down here we have 7 pi over 4. Last, 8 pi over 4 is equal to 2 pi. You can keep counting if you want. For example, pi over 4 is the same as 9 pi over 4. You can get the degree measures just by counting up by 45's as well. The last part of the unit circle that you're going to see are the ones that are measured at a 30-degree angle and at a 60-degree angle, like this. And those are going to be similar triangles to each other. If you got a 30-degree angle versus a 60-degree angle, they're basically the same shape. Well, one way to think about this is that if I count by 30 degrees, I go 30, 60, 90, then another 30 makes 120, another 30 makes 150, and then I land directly on 180. It takes 6 of those counts, 1, 2, 3, 4, 5, 6, to get to 180. So I know that my 30-degree angle has to be a sixth of the way to pi over 6, because it took 6 copies of 30 degrees to land on 180. So each 30 degrees is pi over 6. That means 60 degrees would be 2 pi over 6. This would be 3 pi over 6, 4 pi over 6, 5 pi over 6. So I'm going to label those, but I'll just reduce them. 1 pi over 6, 2 pi over 6, reduced to pi over 3. 3 pi over 6, already been reduced. 4 pi over 6 reduces to 2 over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 is already reduced. Then we have 7 pi over 6, 8 pi over 6, 9 pi over 6 that's straight down, 10 pi over 6, and 11 pi over 6. So we can add those in. 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 reduces. 10 pi over 6 is 5 pi over 3, and 11 pi over 6. And we have all of our radian measures. So that's the angles part. The last thing I'm going to do is talk about the measurements that you need to use. And I'm only going to talk about the first quadrant of it. And I'm going to actually clear the screen here just to give myself a little bit more space to work with. There's two different triangles that we need to know about. One of those has a 30-degree angle here, a 60-degree angle here, and a right angle here. The other one has a 45 degrees and a 45 degrees and a right angle. Both of these have a hypotenuse of 1. And if you use the Pythagorean theorem, you'll find that this one right here is the square root of a half on either side. The square root of half makes sense because if you set up your a squared plus b squared equals c squared, for my triangle on the bottom, I need each of these values need to equal a half after I square it. So that's why I wrote the square root of half. And the reason they each need to equal a half is because this is equal to 1. Okay? Square root of a half is the same as the square root of 1 over 2. And sometimes you'll also see the square root of 2 over 2. Those are all three the same number. For my other triangle, it's a little bit of a trick, but if I copy it over, it makes an equilateral triangle, which means this is half of a length. And if you set up your a squared plus b squared equals c squared, a half squared is a fourth. That means that this needs to be 3/4 so that I can add up to 1. So I get here the square root of 3/4. So using that, I can fill out the values in the first quadrant. And once I've got the first quadrant, they're just going to repeat in all the other quadrants. So let's start with the 45-degree one. If I look at the 45-degree angle, the lengths of the triangle are the square root of a half. And because that's how long the triangle is, that means my x and y coordinates are both square root of a half. So that's it for the 45-degree angle. If you had to go to quadrant 2, all you would do for the 45-degree angle is keep the same numbers, but you just make the x value negative because you're in quadrant 2. Now let's look at a different angle. Let's look at the 30, 60, 90 triangle. If I go 30 degrees, like this, then I have a hypotenuse of 1. My long side is the square root of 3/4, and my short side is a half. So I know that that has an x value of square root of 3 over 4 and a y value of a half. Similarly to the 30-degree triangle, I can draw a 60-degree triangle, which is just going to turn these two measurements on its side. So square root of 3 over 4 is now my y value, and a half is now my x value. So my new coordinates are 1/2 square root of 3/4. Okay? And all of those numbers just repeat when you fill in the bottom half of the unit circle. So you'll be able to have a reference of the unit circle during this unit, but I think it's really important that you understand where it comes from and that we are using radians to measure the distance that you've traveled around the circle, which is equivalent to measuring the degrees. They're just two different units of measure. And also that we're using our two different right triangles to fill in the coordinates as you go around the unit circle. And those coordinates are just going to repeat as you go around each of the quadrants based on which is positive and negative. All right, so that's it for now. Let me know if you have any questions, and I'm happy to help out.